Hi, this is Tim Smith. I'm with EPA's Office of Air Quality Planning and Standards. In the previous presentation, I talked a little bit about the general requirements for RACT and RACM for PM 2.5. In this presentation, I'm going to be talking about specific control measures that are available and could be considered as part of this development of state implementation plans. So in this talk, I will discuss specific stationary and area source control measures, and I'll also talk about our efforts to summarize measures that EPA and other agencies have done to try to identify the available measures for PM and its precursors. Some general thoughts about point sources. First of all, direct PM has been regulated in some form since the 1970s. What might be called Method 5 or filterable PM has generally been the focus of these programs. So where we are right now is not in an atmosphere of completely uncontrolled particulate matter, but rather we need to ask ourselves, how is the fine portion of that particulate matter different from what we've been regulating all along? So what are the ways that stationary sources or point sources could achieve further reductions in the fine fraction of those particles? Well, first of all, you could achieve reductions by improving the performance of existing control devices. Secondly, it could be done by improving the capture of the fine fraction of the PM particles. Third, you could identify ways of mitigating malfunctioning control equipment. And finally, there may be ways of upgrading existing control devices. Generally, the analysis of the impacts of these types of control measure improvements involve some fairly case-specific engineering. It's likely going to be difficult to work with the emissions inventory information that we have to identify these types of situations. For example, you're not going to find in the NEI, or National Emission Inventory, whether control devices are undersized. You're not going to find good information on engineering aspects that would tell you whether the fine fraction is well controlled relative to other sources in that category. And it's not going to tell you whether increased capture of the emissions is possible. So it's likely going to involve a fairly intensive case-specific engineering study to identify the degree to which these types of measures could be effective. Here are two references that you may want to consult in looking at ways to improve point source control devices. The first reference was a study done for OAQPS by Pekin and RTI, which looked at potential ways and what emission reductions could be achieved by these types of control device improvements. The second reference is from the Institute of Clean Air Companies, summarized 16 papers on ways to improve devices. Both of these references can be obtained from a website I'm going to discuss in a few minutes. There are two broad types of control device improvements. The first type, and these are summarized in the Pekin and RTI report, are improvements to existing devices, and the second are what are called innovative upgrades or technologies, new types of technologies. The Pekin and RTI report summarizes a number of ways to improve existing devices, some which may be familiar to you, including improved monitoring, addition of conditioning agents, improved filter fabrics for baghouses, and the like. Two examples of these innovative PM 2.5 controls that are summarized in the Pekin and RTI reports are COPAC and the indigo agglomerator. Again, just examples of this sort of thing. COPAC is often referred to as a polishing filter, basically a relatively small baghouse downstream of another device, which allows the device to overall achieve a very high degree of particulate removal in the fine fraction. The indigo agglomerator is located upstream of an electrostatic precipitator and provides an upfront charge to increase the overall collection. Now I'd like to talk about a few category-specific point source topics, including controls for integrated iron and steel mills, stationary diesel retrofits, and SO2 controls for various stationary source categories. With respect to steel mills, which are a very important source category near a number of non-attainment locations for PM in the eastern United States, EPA did a study upon request by the state of Michigan. This study, which is included in a contract report by RTI, is called Evaluation of PM 2.5 Emissions and Controls at 2 Michigan steel mills and a coke oven battery. This summarizes a number of measures, a number of locations at these facilities for which further control is achievable. Well, in this report, the measures were specific to the 2 Detroit facilities. It still may be of use to other steel mill locations in looking at whether the measures that were identified in this study may be available for those other facilities. The second type of control measure, which I'd like to talk about, is stationary diesel retrofits. While often stationary diesel engines are used as backup or emergency power, some are in prime use. An example of prime uses would be those for remote generation and to power industrial motors and equipment. While it's uncertain what the magnitude of stationary diesel retrofits is with respect to non-attainment in urban areas, there are certainly feasible controls to retrofit stationary engines. Of course, the 2 examples being the oxidation catalyst and the diesel particulate filter. These are the same types of controls that are used in school bus retrofits and other diesel engine programs. With regard to point source emissions of sulfur dioxide, I'll talk about a few categories for which controls are available. For industrial boilers, available controls include flue gas desulfurization, scrubbers, fuel switching, and for those burning oil, the use of lower sulfur distillate. For petroleum refineries, we may be getting to the point where most of the nation's oil refineries are covered by enforcement settlements. But to the degree that that is not the case for refineries which have not been looked comprehensively in this way, those settlements point the way to controls for fluid catalytic cracking units, sulfur recovery plants, and process heaters. Another SO2 category is sulfuric acid plants. Sulfuric acid plants vary somewhat widely in their SO2 emission rates per unit of sulfuric acid production. You can see from our AP42 emission factors, the SO2 emissions is a function of the conversion efficiency. So by adding additional absorption, some facilities have been able to reduce their sulfur dioxide emissions significantly. And for information on this, I would refer you to enforcement settlements for a number of sulfuric acid plants. With regard to cement kilns, NESCOM looked at SO2 controls and their best available retrofit technology, or BART, reviews for the visibility program. It's also important to note that we expect a certain amount of SO2 emission reductions from a national regulation for cement kilns. So the need for state implementation plans for PM 2.5 to look at the cement industry may be affected by the final standard for the cement kiln NESHAP, which is expected soon. Now I'd like to turn my attention to area sources. Area sources are those sources which individually may not be important, but collectively can add up to significant emissions over a non-attainment area. Examples of area sources with controllable emissions include wood stoves, restaurants, open burning for purposes of land clearing, and the sulfur content of heating oil. I'll talk about the latter three categories here, and we'll leave to Larry Brockman, who will be talking about wood stoves to some detail in another presentation. We've taken a look at emission inventory data in a number of eastern non-attainment areas, and it appears that commercial cooking is a significant contributor to those inventories. For total particulate matter, typically restaurants contribute 2 to 4% of the total PM, but for the organic carbon fraction, which we see as an important part of the PM monitored concentrations, we see typically 6 to 12% of the inventory in these areas is from restaurants. The inventory consists of basically three types of cooking operations. The first is called the conveyorized charbroiling, which consists of grilling in an entirely enclosed fashion, which consists of about 10% of the overall restaurant inventory. The second type, which is a bigger portion of the inventory, nearly 75%, is from under-fired grilling operations. And other miscellaneous cooking operations make up the remaining 15%. Conveyorized charbroilers have been regulated in California for a number of years, starting with the South Coast Air Quality Management District in the late 90s, and in other California agencies more recently. The types of catalyst controls that can eliminate the emissions from these facilities is in place at many corporate-owned facilities in the eastern United States as well. For under-fire grilling, the emissions are more difficult to capture because of the higher flow rates and lower temperatures. And in particularly, there's problems with the catalyst technology that's used for conveyorized charbroiling as a result. Under-fired grilling is, however, regulated by the Bay Area Air Quality Management District, which looked at a number of different types of controls other than catalyst technology as the way to reduce the emissions. I would refer you to the staff report and other efforts by the Bay Area if you are interested in seeing the achievable controls for this category. With respect to land clearing open burning, the state of Washington bans this type of open burning for land clearing for development in what they call urban growth areas, and I include a link to that ban. Alternatives to burning land clearing for development include chipping, shredding, and landfilling. EPA has estimated this at approximately $3,500 a ton. Now that I've talked about some of the specific control measure information, it's also useful to talk about where you can obtain further information beyond that which I could summarize in this talk. We have a website where we note a number of these references, including a menu of options for PM and precursors that was put together by Stapp and Lapco, of course now known as NACA. We also on our website have a summary of control measures. And we link to a number of state efforts, including efforts in New Jersey, California, and elsewhere. While perhaps more important for the coarse fraction of particulate matter than for the fine fraction of PM being discussed today, I would like to note that the Western Regional Air Partnership, or WRAP, has put together a comprehensive document which talks about the types of measures that could be used to mitigate fugitive dust. I'll talk just a little bit about nitrogen oxide or NOx controls. because much work has been done on NOx for ozone with respect to EPA's interstate rules and elsewhere. There are many references for NOx controls. At a website that I note on this page, you can see a listing of a lot of those references. The technology for NOx continues to advance, so I'd encourage you to look at all references with respect to NOx controls. One document I would like to point out, however, is the Institute of Clean Air Company's evaluation of the time needed to install various NOx controls, such as selective catalytic reduction, or SCR, SNCR, and the like. So, in summary, what I'd like to say is a number of local measures are available to consider in your state implementation plan for particulate matter. EPA and state and local agencies continue to work to identify local control measures for PM and its precursors. Your charge is to consider these measures and others to determine the most effective control strategies that would apply to your particular non-attainment problem.